Hey guys, and welcome back to day 11 of our online learning. Today, let's go over a few things. So, first, we're going to go and do announcements. Then, I'm going to explain sort of how the assignment for today works. And then, after that, you sort of have an option. So, the assignment is structured in a way that you're going to sort of get this lecture through the resources on your own. But if you'd like to stay and have me sort of explain what's going on, then just watch to the end of the video. All right, so that way you know where all the important information is. So a couple of things. I'm gonna drag myself over here and we're gonna look at the calendar together. Woohoo! Yay! Actually, just kidding. I want to be in the middle. Yeah. All right. Today is the 26th. You are watching this video either of these 2 days. We are going to finish up our topic of gravity using Kepler's laws of planetary motion. And then after that, we will be taking a pretty short formative quiz. Maybe it's I don't know. Actually, I think I'll do a Google form. Definitely do a Google form. Okay, we'll be taking a quiz on Wednesday and Thursday. It will be open resource and not too long, not super math heavy, but there'll be some problems, which is why we did a couple of those practices before. After that, seniors, of which I think I have about 20 of you, so about a full class of you. This is pretty much it, right? This is your last full week. On the 6th, you are turning in your Chromebooks and etc. I will just sort of let you know now that the 4th and the 5th, I sort of have designated as sort of catch-up days for you. If you have any missing assignments, this is your time to get them turned in. I will be available to help you, walk you through those assignments, etc. If you want to boost your grade up a little bit, if there are assisted assignments that we've done, you're welcome to go back and sort of add to them using the corrections I've given on your assignments. Everyone can do this, but this would probably be a priority for those of you who are leaving soon. And just, yeah, I really enjoyed having you guys this year. Even if I didn't have you the full year, I'm going to miss you. Expect something in the mail. And if you need like a recommendation letter, or if you need help with science stuff, or you just want to send me really good science memes afterwards, then you have my email. Stay in touch with your teachers afterwards. Okay? We like hearing from you. It's great. It's very rewarding. For everybody else, you've got 4 weeks left. Probably not what you wanted to hear. Sorry about that. So this week we will finish up gravity, and then we've got about 3 weeks, 3.5 weeks of electricity, which is our final unit. So bittersweet. Okay, so we've got this week of electricity, and then this is Memorial Day, right? Labor Day. I hate to say it. I get them confused, honestly, which one's in May and which one's in August. Doesn't matter. You're out of school that day. I mean, it does matter. I understand that they're important. Okay, you're out of school this day, and then this is our final day. Don't ask me about finals, because I don't know anything. So that's fun for all of us. Woohoo. So this 3 weeks we got for electricity and a finish up day. Not sure what that's going to look like. And I'm not going to lie to you guys. These are the 2 best units to actually have been in class for. And it's a super bummer that we weren't, because all we were going to do for gravity was basically do the stuff that we did, but quicker, and then play around with the telescopes. I was probably going to make you watch Interstellar just because I really like it. And then after that, for electricity, half of it is just playing with all the circuit boards. It's literally just me giving you a kit and just saying, hey, make the light bulb turn on, record how you do it. Awesome. So we're still going to have some fun here, but unfortunately not as much fun as we would have had. If you are, interested in that kind of thing, or just think it would be fun, I'm probably going to have a flex session when we come back, in which if you would just like to sort of schedule yourself in, catch up on some things, and play around with the circuit kits sort of as we catch up on things, then go for it, because I miss you guys. All right, and with that, let's talk about today's assignment. So today we're going over Kepler's laws. There is an attendance form right here. It's got 2 questions about science, which are more about your opinion about science. I've been trying to sort of make these Google forms a little bit less on just the, questions about what we're learning, and more about thinking questions, like, what do you think about these things? So they're more about the nature of science, maybe the history or the processes or how things things sort of happen. And then after that, there's one fun question, which I enjoyed, and I'll probably enjoy reading your responses. After that, there's a couple of videos, which we will get into. The best of which, though, is right here. It's from NASA. It's sort of a 6.5 minute or so overview of orbits and Kepler's laws of motion. And then after that, you are going to create something. So the standard for this unit is, I'm going to drag myself back over here. The standard for this unit is to make a model of what's happening. But there's lots of different types of models, right? And so I'm going to give you guys sort of an option. So your instructions are to watch the videos on Kepler's laws. There's one here. Let me scroll to it. Just at the end of that gravitation PowerPoint. Don't forget that that is right here under gravity slides. But there's also the one in the assignment from NASA. Afterwards, you're just going to choose an assignment on the list to help you answer your questions. And then you will be able to use this assignment on the quiz on gravity for Wednesday/Thursday. So these are your guiding questions, each one sort of to help you explain one of Kepler's 3 laws. So number 1, just what are they? What are Kepler's 3 laws? Brief description / explanation of each one. What does the first law tell us about the solar system? So these kind of go in order of corresponding to the law in which you're describing. So why is it geocentric? You're going to hear this word a lot. Geo means Earth. Centric means the center. So the geocentric model of the universe, you guys know, it just means everything rotates around the Earth. How is that an impossible scenario? And why would it seem like it wasn't? Just a thought. Do planets orbit the sun in a constant... Oh, that's supposed to say at. Also get Grammarly, just FYI. At constant speed, or does that speed vary? Support with evidence. And how do the orbits of outer planets like Neptune compare to the orbits of planets closer to the sun like Mercury? Do their periods sort of correlate with how far away they are from the sun? All right, and then here's your assignment. There's lots of things that you can do here. I can kind of explain each one shortly. So whatever your assignment is, whatever you turn in, the thing that I'm grading you on is, did you actually answer these 3 questions or these guiding questions? Did you sort of explain what Kepler's 3 laws were? And did you do that in sort of a unique, maybe not unique, I'm not grading you on creativity here. I am grading you though if it is like your own work. Does that make sense? I'm not going to say, oh, you forgot to color it. I'm disappointed. But I am going to say, oh, you copied and pasted. How wonderful. I could have just read that Wikipedia page myself. Thanks. So your assignment options, there's lots of different ones. You guys are welcome to pick whichever one just seems the most appealing to you. You can sort of I put a mini poster in here just because I assume none of you have just giant white sheets of poster paper laying around, but like go for it. Upload a picture. You can just draw a picture of some planets and divide it into 3 sections. Here's the first law, the second law, the third law. Here's what they do. Here's the answers to the questions. Boom, done, happy. Upload that as a picture. You could also make a different version of it using Google Draw or whatever your proposed editing software is. Create an informational brochure, like a sort of foldable, if you guys remember those foldables. It's sort of the same thing as my infographic, but whatever, just either way. You can draw like a comic book type version. I actually asked for this one year and I got super excited about the results. So really into that. Make a slides presentation of Kepler's laws. So just a slide per law of what's happening, what it is. You could record a video of yourself explaining the law / answering the questions. If you want to use this using Screencastify, it's super, super easy to use. And you can actually upload things to your YouTube account. Thinking about making YouTube videos once all this is over. Boom, for skills. Record a video of yourself explaining the law / answering the questions. Bonus points if you pretend to be Johannes Kepler. The better you are about your former advisor sort of shutting you off to the side and basically ignoring half of your research, then the higher I'm going to rate you. Write a 3-paragraph summary of the laws and the answer to the guiding questions. Short stories, dialogues, poems, I don't particularly care about the format. I just like you to be creative with this. Have some fun. Kepler's laws aren't that exciting, and they're especially not that exciting because, or maybe exciting isn't the right word here. Um, it's a lot of math, but we're not using the math. So you're just describing like what's going on. So that's why this is meant to be as many options as possible to get that information across. If you have a way that you would like to define and explain Kepler's laws of motion and sort of, again, answer these guiding questions are about each particular law, then go ahead and go for it. Just let me know afterwards. All right. A quick note on your rubric. This is for an actual grade. It's for an assisted grade, and it's really kind of like an all or nothing sort of thing. So to get a 5 on this, you just didn't describe all 3 laws. You wrote one thing and you just kind of like left it at that. So some points, but not really. For an 8, so notice there's nothing about this about how unique or creative you are being. If creative things are not your thing, first of all, I'd like to say that everyone has at least one creative thing that they like. But if this sort of artistic sort of style of presentations isn't really your thing, then choose the 3 paragraphs. Choose the Google Slides. Go for it. Use whatever works for you, dude. You can only get an 8 if you basically you did all 3 laws, but just some of your information wasn't quite right, it was a little bit inaccurate, you were missing some stuff, you forgot to answer a few questions, etc. A 10 just for basically doing this in a creative way. Don't even care what. Just you put some effort into it. You described all 3 laws. It looks good. Looks accurate. I like it. Go. We're good. So if that is all for you, then go ahead and stop this video. Watch the 2 videos on Kepler's laws. The one from NASA, I'll let you know, is the best one. For everybody else, if you'd like to stay on real quick, then I'm going to sort of explain a little bit of information about them. But first, some history. Okay, and let's hide this for now. All right, back to my favorite PowerPoint presentation. Woohoo! Okay, planetary orbits. Here's a quote from a book I like. Moving on. Okay, Kepler's laws. So a couple things you guys need to know first. Number 1, people have known that the Earth was round for a really long time, about since 400 BC. However, the idea that the Earth was not the center of the universe, that's pretty new. The first person to sort of propose this that we have a recorded section of is a guy, I had to write down all the names. Okay. Aristarchus of Samos had this idea in about 300 BC, so it's been going on for a long time. A lot of other people sort of had the idea like, hey, maybe the Earth isn't the center of the universe, and then it didn't really go over well for them. But this idea sort of circulates around in history a few different times. So you have it pop up in ancient Greece, you have it pop up in ancient India, in the medieval Islamic world, both of which, by the way, never get credited for having a lot of great scientific and mathematical ideas, even though they sort of kept a lot of things alive until they could be rediscovered for the first time in medieval Europe during the Enlightenment movement. But whatever. All right, then you finally have Copernicus come around. And so here's the thing. For a long time, people thought that everything had to orbit the Earth. And they thought this for a few different reasons. Number 1, just sort of like if you look outside, you would observe the planet sort of moving, it looks like in correspondence to you. That's because we're on Earth, so we're the one making the observations here. So just with your naked eye, it would be easy to sort of get the idea, oh yeah, the sun comes up, the sun comes down, the moon, etc., the stars. Okay, everything seems to be moving around us, therefore maybe we're the stationary ones. But if you really do close observations of the stars and the planets, then all of a sudden this doesn't make quite as much sense. And people put a lot of effort into it making sense because it gave the idea that if the Earth is the center of the universe, then everything is sort of as it is supposed to be. Humans must be the most important species, and therefore we are at the center. Earth, therefore, must be the most important planet, and therefore it must be at the center, and our solar system must be at the center of the universe, and so on and so forth. I read a really good thing actually that said all of science that people sort of take sort of issues with is really just the idea that maybe we aren't the most important things out there. And that's usually the part that sort of gets people. So it's understandable. That's just the ego. Here it is. Anyway, so off of that train of thought, you can tell it's been a while since I talked to people besides my husband or my dog. Let's see. So a lot of people had the idea that maybe the Earth was at the center of the universe. Copernicus first gets a lot of most of the credit for this, and then later on Galileo. Oh man, what a guy! Does a lot of cool things, but his support for the Copernicus theory is what really lands him into a lot of trouble. Galileo, as you guys will know, was eventually put under house arrest by the Pope. To be fair, a lot of that was because he was in really good standing, right? Like he was a noble, he had a lot of credit to his name, he was considered to be a great scientist. So he had to do a lot to get put under house arrest. And the fact that he was just put under house arrest and not immediately executed really says a lot about how sort of well liked and popular he was, because in any other world, he would have been definitely executed. So he was asked by the Pope, "Hey, I know that you like this idea that maybe the sun is the center of the universe, but maybe you should publish sort of something where you give credit to both sides." And at the time, whenever you publish a scientific paper, it sort of looks like a dialogue between two people, and they're sort of explaining the pros and cons of each side, which is kind of cool. So Galileo does this, and his person who is against the idea of the sun at the center of the universe is the Pope, but he names the Pope the simpleton, literally, in his play, in the ultimate act of shadiness, and this gets him thrown in house arrest, because maybe during the Middle Ages, when you live in Spain, you shouldn't insult the Pope. Just a thought. All right, so finally we get to Johannes Kepler, who comes up with laws. As you guys remember, laws and theories, kind of the same thing, but laws typically have an equation or formula with them. So Kepler's laws are 3 equations or mathematical relationships that sort of describe how planets, all planets, by the way, not just planets in our solar system, interact with each other in their orbits. And this supports the heliocentric theory of our solar system. Heliocentric means sun at the center. Heliocentric theory comes from a lot of different theories. So let's dive into these 3 laws. So as they are, the very first one is fairly simple, and that's the idea that planets do not move necessarily in a circular pattern. They move actually in ellipse. So an elliptical pattern is sort of an oval-like pattern with the sun as one of the foci, or the sort of focus of that ellipse. The second law, as a planet moves in its orbit, it sweeps out an equal amount of area in an equal amount of time. What does that really mean? It means that planets, as they orbit the sun, sort of speed up and slow down at select times during their orbit. That's all. And then finally, the third law, the period of a planet increases as its distance from the sun increases. So these 2 things increase together. And it's actually a really reciprocal relationship. So the period for a planet is the number of days in a year. For Earth, we have 365.25, and that's where we get the leap year from. We have to tack that 0.25 days on somewhere. So for other planets, it varies. Your years for one rotation around the sun get longer as you get further away from the sun. And this is a direct relationship. So as that period increases, so does the distance from the sun. And that is the same for each thing. So this is a infograph of 3 laws. So the first law, boom, this is an ellipse. Notice how it doesn't look like a circle. It looks kind of like an egg. Actually, it looks a lot like an egg. The second law, equal area in the same amount of time. This much area, this much. So notice how, if this is an ellipse, as it's kind of closer to the sun, it might go a little faster here, a little slower here. That's okay. And then finally, the period, the time for one cycle, divided by the length of like the axis of the diameter, you could say, is the same for all planets. So no matter how far away they are from the sun, the relationship between the year and their distance from the sun is going to be a relationship that's kind of the same for all planets. It's like a ratio that stays the same. Okay. After that, we've got a short video here explained in 5 questions from Encyclopedia Britannica. But I also really, really like the NASA version. Okay. So watch both videos for just extra support, or just watch the NASA one. Okay, up to you. And with that, I hope you guys have a good night. Make sure on the quiz on Wednesday and Thursday that you use this assignment to your advantage, and also perhaps that you have other notes from gravity and that you feel okay about the universal gravitation problems. There will be a few, but it won't be any of the too tricky ones, okay? We're just going to go real basic. And with that, have a good night.